In section 4.9, part 2, we are going to look at graphing a system of quadratic inequalities. So we have two different quadratic inequalities here. We're going to graph them in the same coordinate plane. So that means we're going to need two different tables, each with 5 sets of points. So we're going to have two parabolas. So we need to identify the vertex for each of them first. So I've got the first equation, which is in the form of y equals ax squared plus c. And we know the vertex in this form is going to always be 0, comma c. The second equation is in our y equals ax squared plus bx plus c, where you have to find the vertex, you have to first identify the axis of symmetry. Which is using the equation we used in the first part, x equals the opposite of b all over 2a. So I've got my first equation, which is y is less than or equal to negative x squared plus 4. The vertex, easily identifiable, is 0, comma that c value, which is positive 4. So that one's done. Second inequality, which is y is greater than x squared minus 2x minus 3. We have to do a little bit of math. So first we want to find our axis of symmetry, which is x equals the opposite of negative 2 all over 2 times 1. Two negatives make a positive. So we've got 2 over 2, which is equal to 1. So our x value of the vertex is 1. Our y value is, I'm going to plug in the value of 1 into the equation. So I've got 1 squared minus 2 times 1 minus 3. So you evaluate that. 1 squared is 1. Negative 2 times 1 is negative 1. So 1 minus 2 is negative, or 1 squared is 1. Negative 2 times 1 is negative 2. So 1 minus 2 is negative 1. Minus 3 is negative 4. So the y value of my vertex is negative 4. So the vertex here is going to be 1, comma, negative 4. So we're going to use that information. Here's the vertex. I'm going to put the vertex in the center in each spot. And we want to increase by 1. So I'm going to go from 0 up to 1, then up to 2. I'll go down 1, down to negative 2. And then I'll come back and I'll finish this one up later. Alright, so we want to evaluate, alright, what the value of y is when x equals 1. So I'm going to plug 1 in. 1 squared is 1. Take the opposite of that. We have negative 1. Negative 1 plus 4 is 3. So if this value is 3, this value is also 3. Then I plug in 2. 2 squared is 4. Take the opposite of that. I get negative 4. Negative 4 plus 4 is 0. So if this value is 0, this value will also be 0. So I'm going to come here and do the same thing. Populate this table. So if my vertex is at x equals 1, that's the axis of symmetry. I'm going to go up by 1 to 2. Down by 1 to 0, up by 1 to 3, down by 1 to negative 1. I will plug in the value of 2 in for x. 2 squared is 4. Negative 2 times positive 2 is negative 4. So I've got 4 minus 4 is 0. Minus 3 gives me negative 3. So both these values are negative 3. Then I'm going to go ahead and plug in 3. 3 squared is 9. Negative 2 times 3 is negative 6. So 9 minus 6 is 3. 3 minus 3 is 0. So both these values are 0. Now that we have that, we can plot our points in the coordinate plane. So I'm going to first start with this vertex. So I'm going to plot 0, comma, 4. Then I'll plot the rest of the points for that parabola. 1, 3. Negative 1, 3. And then 2, comma, 0, negative 2, comma, 0. Before I connect the dots, I want to double check, do I have a solid or do I have a dotted line? The inequality of less than or equal to, the or equal to, tells me I have a solid line. So I'm going to come on here and connect the dots to form my parabola with a solid line. Then I'm going to come on over here and plot these points in the coordinate plane. So the vertex is 1, -4. So 1, and I'm going to go down to -4, 2, -3, and 3, 0, 0, -3, -1, 0. Is this a dotted or a solid line? I'm going to come over, look at my inequality symbol and see it's greater than. There's no or equal to, no little line underneath, so I do know I have a dotted line. So I'm going to connect these dots with a dotted line. And then the last step will be shading. I have to use a test point and shade for each of these inequalities. So for me to use my test point, I'm going to rewrite the inequalities below. So we've got y is less than or equal to -x² plus 4. And over here we had y is greater than x² minus 2x minus 3. So by rewriting, it just kind of helps me. Alright, so I don't have to scroll up and down on the screen. I'm going to use 0, 0 for both of them because neither parabola passes through that point 0, 0. Remember, you can never choose a point as a test point that falls on the parabola. So I have a test point of 0, 0 here. So I'm going to plug in the y value of 0. I'm going to plug in the x value of 0, so the opposite of 0² plus 4. And evaluate. So I've got 0 is less than, 0² is 0, the opposite of 0 is 0, 0 plus 4 is 4. Is this true or false? This is true. So I'm going to shade the region with the test point for -x² plus 4. It's negative, so I know it opens down. I know the vertex is at 0, 4. So I'm going to shade inside this parabola with the solid line. Now I want to go ahead and look at the shading for this parabola with the dotted line. So I'm going to use the same test point of 0, 0. Plug in the y value of 0. So I've got 0 is greater than 0² minus 2 times 0 minus 3. 0² is 0. -2 times 0 is 0. So 0 minus 3 is -3. So I see the statement 0 is greater than -3. Which again is true. So I would like to shade the region with the point, the test point, which is 0, 0. So again, that is inside the parabola. So I'm going to shade the area that's inside the parabola, and my solution will be where the two shadings overlap, and that occurs right in here where I have green and purple diagonals. And as you see, I shade it, the purple kind of changes to red, going back to art class. Alright, so here is my solution. Alright, and this is part 2.